So who can tell me what the unit rate is going to be for 20 miles in 2/3 of an hour? We do 20 miles in 2/3 of an hour. What is that going to be, Natalie? 30 miles per hour. So when you're doing the unit rate, remember it's going to be your first measure, 20 miles, over your second measure, which is the 2/3 of an hour. And to get it to a unit rate, you're going to divide both the numerator and the denominator by whatever the denominator's measurement is. So we're dividing both of these values by 2/3. And if we divide 20 by 2/3, that's going to give us 30, so it's 30 miles. And then 2/3 divided by 2/3 is 1, so it's 1 hour. So it's 30 miles per 1 hour. You could write 30 miles per hour or 30 miles over 1 hour. Either of them is fine. Okay, for problem number 2, we have 1/4 of a cup of baking soda for 3 batches of cookies. What is that unit rate going to be? Darius? Not 12 cookies. Dylan? 1/12. What?
Cookies?
Not cookies.
No, not cookies. Batches of cookies.
Not batches of cookies either. So we have to read it in the terms of what it is. So you're setting it up as 1/4 cup of the baking soda over 3 batches of the cookies, right? You're dividing both the numerator by 3 and the denominator by 3, and that's going to give you 1/12 cup of baking soda per 1 batch of cookies.
So you do it like in order, so say it was
Do it in the order that's given to you unless the question phrases it differently. So if the question wanted to know batches for 1 cup of baking soda, then you would do 3 batches over 1/4 cup. If the question asks you to do it in a different order, then you phrase it in the order the question's asking you. When it's just giving it to you this way, you do the first over the second. Okay? For problem number 3, which one of these is going to be the better purchase? Like a better deal. It's going to wind up being cheaper in the long run. Ken? What did you get for the price per can? Remember, we always do money divided by items. Should always do money divided by items. So you should do $6.28 divided by 4, and that's going to give you $1.57 per can. Okay. What about for the 7 cans? What's that price going to be? Oh my God. I just came to a blank. Yeah. Ava. I had a blank in my mind. So Ava, it's going to be what? 149. It should be 149. You have to round correctly. So if we do $10.40 and divide it by 7, it's going to come out to 1.4857. It keeps going. But that 5 is going to tell you to round that 48 up to 49 cents. So it's going to be $1.49 per can. So which one's the better deal? The $10.49 for 7 cans. This is the better deal. Okay? We want to go with which one's cheaper for us, a cheaper purchase. Okay? All right. Go ahead and get those papers, the proportional and non-proportional papers out. You're just going to write on them right now, and then you'll glue it in after we're done with the notes. Harold, can you wake up, please? If you don't have them, you can't find them, then go ahead and you're just going to have to get them copied into your notebook. All right, so we're talking about proportional and non-proportional relationships today. So when we're talking about proportionality, that means that you have a constant ratio, or otherwise known as a constant rate of change. We know it right now as a unit rate. So go ahead and underline or highlight, we'll do that in green, that two quantities are considered to be proportional if there is a constant ratio or a unit rate, otherwise known as a constant rate of change. Now, if there is not a constant rate of change, then it's considered to be non-proportional. So when we're setting something like this up, what we're trying to do is we're trying to create a situation or a scenario or table to identify if we have a constant rate of change or not. So what we're going to do is, given this first situation, it says Andrew earns $18 per hour mowing his lawns. We want to know if this is a proportional relationship, if the number of hours is proportional to the money that he's makes. So is the money proportional to the hours that he's going to spend mowing? So what we're going to do is we're going to set up a table of information. So it says that they want money compared to hours. Money compared to the hours. So if he were to work 1 hour, how much money would he make? $18. If he were to work 2 hours, how much money would he make? $36. If he were to work 3 hours, how much money would he make? Okay, and we'll do one more. Let's say that he works 4 hours. How much money would he make? 72, right? He makes $18. So every time we increase an hour, we're increasing our money by $18. That's what's happening. Started off with $18 for 1 hour. When we went up another hour, we added $18 onto it. So 18 plus 18 is 36. When we add another hour, we're adding $18 here. So 36 plus 18 is 54. So if you needed to write that down, you can. Hey, I'm increasing here by 18, then I'm increasing here by another 18, then increasing here by another 18 in order to be able to get to my next amount of money per hour. So what we want to know is this proportional. So if it's proportional, when you simplify them to a unit rate, it should all be equal. So let's start with the very first one. We've got 18 over 1. What does 18 over 1 equal? 18. Okay. Then we've got 36 over 2. What is 36 divided by 2? 18. Then we've got 54 over 3. What does that equal? 18. Okay. You realize you're being recorded, right? Oh, yeah. Okay, then the last one we have is 72 over 4. What is that? 18. Okay, so we're getting 18 across the board. That means that this is a proportional relationship because we do have a constant rate of change or a unit rate. So it is proportional. Okay, so let's take a look at problem number 2. It says Uptown Tickets charges $7 per basketball game ticket plus a $3 one-time processing fee for the ticket order. We want to know again, is the cost proportional to the number of tickets? So we're going to have the price, the cost, versus the number of tickets. So when he buys that first ticket, how much is that going to cost him?
$7. $3. No, wait, what?
$10, right?
Yeah, I told you.
It's $7 for the ticket plus a $3 one-time processing fee. Right? So it's going to be $10. You've got to do that 7 plus 3, which is going to equal 10. So it's going to cost him $10. Now, when he buys the second ticket, how much is that going to be?
$20.
Think about it. It's a $3 one-time processing fee. So it should be 17 because he's buying that second ticket. He's just going to have to pay the extra $7 for the next ticket. So we're now at $17. What about for 3 tickets? What's it going to be? 24. Because again, you're just paying the next $7 for the ticket. Shh. And then what about 4 tickets? $31. Very good. Because again, after you've paid that one-time processing fee, you paid it only the first time, each ticket you buy after that, you only pay for the ticket, not the processing. Does that make sense? Okay? So you only pay the processing fee for the first ticket. You don't pay it any time after that.
The processing fee is the $3.
Is it $3? The tickets are $7. So every time you're buying an extra ticket, you're just increasing by $7. So now let's check and see if this is proportional or not. We've got the value 10 over 1. What's 10 over 1? 10. Okay. Then we've got 17 over 2. What's 17 over 2?
Something decimal something.
You should have a something calculator something.
8.5.
8.5.
Yeah, see, I told you that.
So we have 8.5. Then we've got 24 over 3, which is
3.
8.
I mean, no, 9.
8.
9. I got a whole 9.
24 divided by 3. Yeah, guys, remember you are being recorded. This is getting uploaded. Okay? And then 31 divided by 4. 31 divided by 4 is what? 7.75. Okay, so now you notice that none of these are the same. So this is not proportional. This is non-proportional. Non-proportional. Now, here's a nice little tip. If you look here, something that's unique for being proportional versus not being proportional. When it was proportional, we had a coefficient, right? $18 per hour. Did we have a constant? No. You only had a coefficient. You did not have a constant. But when you look at number 2, you had a coefficient, but you also had that constant, that one-time value, a starting point or a one-time occurrence. Remember, we called those constants. So the unique thing about proportionality, when it's proportional, that unit rate is our coefficient, and there is not a constant available. But when it's not proportional, so non-proportional, a constant is present as well as a coefficient. Okay, so here that $3 one-time processing fee, that was a constant. It was a one-time occurrence, and that creates a non-proportional relationship. Because even though you do have a rate that you're increasing by over and over and over again, that one-time value throws it off so that it's no longer proportional. Dylan? Yes.
My first question is, so all of relationships or whatever,
Uh-huh.
all of them, if they have a constant, like no matter what, it's
It's going to be non-proportional.
And my second.
They will always have a coefficient. There will always be a coefficient, but there won't always be a constant. If a constant is there, then it's non-proportional. Okay, now a constant is not the same thing as a constant rate of change. A constant rate of change is your coefficient, your unit rate. So I'll even write that up here. We call that our coefficient.
And my second question.
Yes.
Is, oh yeah, why is it called constant? Like, why is the one that only occurs once a constant?
Because it will never change. When you have a coefficient, your value is always changing. But a constant, it's always at one value. It's not going to change. It's consistent.
Oh, 'cause I say
Okay?
constant happens multiple times.
Yeah. All right. Let's go on to the back. Annie walks 6 miles per day. We want to know if the number of miles she walks is proportional to the number of days that she walks. Is the number of miles going to be proportional to the number of days? So again, we're just going to set up our chart. We've got miles over days. In 1 day, how many miles is she going to walk? 6. In 2 days, how much?
12.
In 3 days.
18.
In 4 days.
24.
Is this proportional? Yeah, because is there a constant?
Yes, ma'am. Wait,
No.
ma'am.
There is no constant. So we know if there's no constant, then that means it's going to be a proportional relationship. But we'll go ahead and double check just to make sure. We like to do the math. 6 over 1 is going to be equal to 6. 12 over 2 is also equal to 6. 18 over 3 is also equal to 6. And 24 over 4 is equal to 6. So this is a proportional relationship. Okay? All right, let's take a look at number 4. It says a recipe for fruit punch calls for 1/2 cup of sugar to be combined with 2 quarts of juice mix. We want to know, is the sugar proportional to the juice? So is the sugar going to be proportional to the juice? So we're going to set it up as sugar to juice. So it says 1/2 cup of sugar for 2 quarts of juice. So when juice is at 2, sugar's at 1/2. So because I'm working with fractions, it's going to be a little iffy. I might go ahead and I'm just going to count instead of by ones, I'm going to count by 4s. It makes it easier for me. So if I increase my juice by 2, then I'm going to increase my sugar by 1/2. Okay, so what's 1/2 plus 1/2? 1. Okay, if I'm going to increase my juice by 2, so that would become a 6. I'm going to increase my sugar by 1/2, and this will become 3 over 2, or 1 1/2. And if I increase to 8, how much sugar should it be? 2, right? If I increase the juice by 2, I increase the sugar by 1/2. And again, guys, these notes will be posted online in case you need to re-watch. Okay? Now, let's check. Let's double check to make sure. We have 1/2 over 2. If we do a 1/2 divided by 2, that's going to give us 1/4. Then we're going to take 1 and divide it by 4. That's going to give us 1/4, or 0.25 if you want to do it that way. If we take 1 and 1/2 and divide it by 6, that's going to give us 1/4, or 0.25. And if we do 2 divided by 8, it'll give us 1/4. or 0.25. So this again would be proportional because there's not a constant present, is there?
No. I know what 5 is.
Okay, problem 5 says Josh has $120 in the bank. Each week he deposits another $20 in his account. Is his account balance proportional to the number of weeks that he's depositing his money? So we want the money to be proportional to the weeks. So starting at week 1, how much money is he going to have in his account? $140, right? He started with $120. He added $20 into the account, so that's going to equal $140 that he has in the account at week 1. By week 2, how much money is he going to have? $160, because he's only adding $20 into the account. Okay? He deposits $20. Every time we increase by 1 week, he's depositing $20 into the account. By week 3, 180. By week 4, 200. So you're increasing each week by $20. Is that going to be proportional? No? What's throwing it off?
The first day.
The first day, because not only is he having $20, but he also has that constant of money that he already has in the bank. So there is a constant. There is a constant, which means it's not going to be proportional. So let's check it and see. 140 over 1 is going to equal 140. 160 over 2 is going to equal 80. 180 over 3 is going to equal 60. And then 200 over 4 is going to equal 50. So those are not proportional. We do not have a proportional relationship here. When we come back from lunch, you will go ahead and do the last problem on your own. You'll find out who's proportional and who is not. Go ahead and line up for lunch.